मैं क्या करूँ? What? Oops. Okay. So, hello guys. Good evening. Am I audible? Audible. Last bench. IIC T-shirt. Am I audible? Okay. इधर देख लो फिर. So I'll be talking on artificial intelligence and creativity. So before we start this interesting discussion, I'd like to ask you a few questions. Okay. So do you guys like to watch the movies? If yes, do this or just raise your hand. Yes or no? How many of you like to watch the movies? Okay, all of it. So did you watch any of these movies? This one is I, Robot, Matrix, Ex Machina, Interstellar. Did you watch any of this? Okay. How were these movies? Good, awesome, best, average, lower than average. This one was of Christopher Nolan, so it would be awesome. Okay. And Dunkirk will be releasing on 26th of July. Go watch that. Dunkirk. The next movie of Christopher Nolan's. Okay, anyways. So these movies are nice. Okay. So like 80-90% guys are agreeing that these movies are nice. Okay. But why is that? Why is it so? Can anybody tell me? Why is it so that we like these kind of movies? These are science fiction movies. Why is it so? Yeah. Yeah, makes us imagine more. Any answer? Any other answer? Yeah, fourth dimension was in this case. Okay. Okay. Nice. Yeah. Right, right. So, like many of the ideas or things that we see today, they were originally got invented many years back in these movies, right? Science fiction movies. So the thing with these movies is these movies fascinate us, right? These are like all of these are science fiction movies, robotic movies. This Stars is a robot, Ex Machina was a robotic movie, artificial intelligence kind of movie. Okay, so these things they fascinate us because the feeling that something we created, something we humans created, can work for us, and to that extent, so like it can manipulate us. So this feeling of creation of intelligence, it fascinates us, right? So originally, AI or artificial intelligence was meant for these things, right? So, but the current state of artificial intelligence is kind of this. You guys must have used like some of these apps, right? Some of these apps or services, Google Maps, Siri, or say LinkedIn or Prisma. Do you guys know about Prisma? It's an iPhone app which later launched on Android. So did you guys use that? Okay. So somehow artificial intelligence has already entered in our lives, okay, in these forms. But the intelligence that was meant here and here is somewhat different, right? This is more and more advanced, right? This is just basics. Okay. So uh, okay, so let's move on. This is a computer. Okay, and to perform any task with a computer, computers are not smart. Basically, the basic general rule is computers are not smart. Okay, we have to make them smart. Okay, with the means of some algorithms and some different things. And with a general computer, some desktop or laptop computer, we have to tell it what to do, right? Whether to perform an addition or subtraction or to plot some graphs or things like that. We have to tell him what to do, right? It cannot learn or it cannot do some of the things on its own. Okay, but artificial intelligence is a leap ahead. Okay, it's a step ahead. Artificial intelligence, the formal definition goes like this. Artificial intelligence is something which gives computers the ability to learn without being explicitly programmed. Okay, did you get this definition? Without being explicitly programmed. Where is the pointer? Oh, explicitly programmed. Okay, what do we mean by explicitly programmed or programming explicitly? Okay, not internally. We are not hard coding it to do some of the tasks. We just write some algorithm which will help the computer to take the data and learn some of the parameters and do the things, right? It will do those things on its own. Okay, so that's what I mean by explicitly programmed. So these computers, without being explicitly programmed, are able to do such things. Okay, in the movies and in these applications, in such applications. Okay. Okay, so current state of machine intelligence. So can you guys give me some of the ideas or some of the examples of current state of artificial intelligence? Use these hints if you want to. Like as of today, what are those intelligent things, so-called intelligent things that we are able to do now? Recommendation systems. Who said that? Just okay. As in what? Yeah, if you buy something on Amazon, there is one little section below that, like people who bought this also bought this or also were interested in this, right? That's kind of recommendation. Okay. Anything else? Ads on Facebook, right? So this Facebook or Google ads, these are smart ads. They, like, your computer saves cookies, or those websites save cookies, and they track your behavior, and then they show you smart ads, or the ads relevant to your recent searches. Okay, anything else? How does this or Netflix or Eco or Airbnb or Prisma or LinkedIn, how does all, like, how are these things working? Yes, spam filters. Google has this inbuilt spam filters. So if you get some mail, if it is like, if Google thinks that it is a spam, it will go to the trash folder or spam folder, right? Any other intelligent things? I just want the current state of machine intelligence. We are discussing about intelligence. Before discussing about creativity, we need to understand what intelligence is. Okay, that's what we are discussing. And I just want those answers which will show me this current state of machine intelligence. Any other answers? This group, only this group is answering. Yeah, Go game or chess game, right? Do you know what Go is? Go is a Chinese game. Do you know what chess is, right? So chess has, say, 64 those squares, and it has some moves, right? If I play this, and there are if I play this move, there are these five possible options which I can play after that particular move, right? Go has like infinity number of possibilities, and many more possibilities that even computers cannot process those possibilities in a finite time. Okay. Okay, anyways. So, any other answer? Take these hints. Google Maps. Have you guys used Google Maps? Yeah, real-time traffic on Google Maps. So you guys must be seeing these hoardings nowadays. Google never used to spend on marketing before few years, but nowadays it is doing ads for Google DU or Google Maps, right? Okay. So any other answer? Sorry? Jobs recommendation. So the underlying principle in those recommendation and the thing that she said, it's same. Okay. Any other answer? Chatbot, Siri. This is kind of chatbot. Okay, but it's inbuilt in your phone, which works on cloud. Yeah. Amazon Go Shopping. Yeah, it recently launched, right? So you don't need to, like, there is no manpower inside Amazon Go stores. Okay, have you guys watched that video, Amazon Go video? Okay, so if you haven't, please check it out. It is awesome. Okay, any other answer? Okay, so that's it. So basically, all of the answers that you guys gave me, I can categorize all these answers into some 4 to 5 topics. Okay, and these topics are identifying between cats and dogs. It's the basic simple thing. Okay, I can identify between this man. This is Stanley, my friend, and this is Pudev, Nitesh. These guys give you the talks. I can identify them, right? I can see him, and I can differentiate. Okay, this is a trivial, too simple task for us humans, but it is not as simple for the computers. Okay, so this is kind of difficult task. So we achieve this first, and then we move on. Okay, so this is one kind of machine intelligence, which is nothing but visual similarities, finding visual similarities. Okay, recently. Nowadays Facebook has this feature. If you upload any photo on Facebook, so like a photo of your friends, if you went to some picnic, so it automatically tags that photo and asks you to, like, whether you want to tag this specific person in that photo, right? So that is also based on this thing, Facebook automatic tags, because it sees the visual similarities between the vast data that your account has and the recently uploaded photo, right? This works on that visual similarities. AI for fashion industry. So the example for this is, say, if I'm reading some magazine, and if I like one photo, there is a man and I like his outfits, okay, the shirts he wore and the pants. Okay, so what I do is I have an app in my phone. Okay, so this is just a startup idea if you want to start a startup in future. Okay, you guys are in third years or fourth years? We just completed third years, right? Okay, so go for it. Finally, fourth year, you have very like too less load in the final years, right? You just have to do your projects. right? So you can take some idea and work on it, okay, in this domain, AI domain. Okay, it will be like all the computer science ideas. You can do it inside your home on your computers, right? So it won't need that much effort. So try some idea, do it. Okay. Anyways, come back to the point. So if I like that outfit, okay, what I do is I clicked the photo of that outfit, okay, and I uploaded that photo into that app. Okay, what that app does is it finds all the similar kind of outfits, just like the photo I uploaded, just like the outfits in that photo, right? And it will recommend me, or it will tell me these things you can buy, and it will give me some links to Amazon or Flipkart from where I can buy these outfits, right? So all these things are related to visual similarities, and many other things are there. The second category is finding the patterns in data and predicting the outcomes. Can you guys give me the example for this? Just raise your hand. Yeah, weather predictions. Okay, so it works on historical data and predict like what will be the weather for tomorrow, today, or day after that. Okay, recommendation engines, just like she said or you said. Okay, recommendation engines work on this. They have lots and lots of data and they predict something on the data. If you like these outfits or these items or these phones in the past, it will suggest you something based on that data, right? The second thing is trading, stock market. Stock market has like this thing has a huge application in stock markets. Okay, and the thing that it is written here is algorithmic trading. You can check it out. It is awesome. The next thing is internal data processing and knowledge bases. What is that? Do you know about behavior tracking? If I have a lot and lots of data about some particular person, I can track his or her behavior, right? And I can like I can give him some personalized services, right? So this thing is used in healthcare companies and in personal or public assistant, just like Siri or Google Assistant. Okay, so if you have Siri, this works on this third category, or Google Assistant on latest Nougat phones. Google Assistant is already there. Okay, so this thing works on that. Okay, and the final thing is learn and generate patterns. So computers or machines will learn something. Okay, it will be with me. It will learn something with my assistance, and it will try to mimic those similar patterns or similar data. Okay, so the good example for this is self-driving cars. So if I drive something for say 2 hours, okay, I build an autonomous car. I drive that car for 2 hours. Okay, it learned my patterns. Okay, it learned how I drive. Okay, and if some car comes next to me, I'll stop, or I'll apply the brakes, or I'll take my car sideways. Okay, so that AI will learn these kind of things. Okay, and will try to mimic the similar patterns in the next situations. Okay, so this is the example of this learning and generating the patterns. IBM Watson. Okay, everyone knows IBM Watson. If you don't, please read about it. I won't discuss it. Okay. Now come back to the basic question. What is intelligence? Okay. So these things we already saw. Intelligence, so-called intelligence that is done today with the help of computers. Okay. Identifying between Stanley and Nitish is kind of intelligence for computers, not humans. Okay. Even some small kid can do that, right? Okay. So these things that we just saw. What is human intelligence? What do you think human intelligence is? Don't tell me about computer intelligence now. Just tell me about human intelligence. What do you perceive as intelligence for human beings? What are the intelligent things? Solving a solving a maths problem. Maths problem. Okay, so 3 plus 2 is a maths problem. Even computer can solve that. Intuitions. Writing proofs. Yeah. So he gave you 2 proofs on that day. Okay, so writing proofs is kind of intuitional. You need ideas. You need original ideas to do that. Okay, anything else? Human intelligence. You all are humans, aren't you? Okay, so think something. Think something. Do you know this famous saying by Rene Descartes? I think, therefore I am. Do you know that? Okay, Liz. Yeah. Yeah, right and wrong. What is morally right? What is morally wrong? Okay, differentiating needs some kind of intuition, some basic principles to it. Yeah, somebody raised the hand in the back. Yeah. Yeah, that is one very nice example. Okay, so if you put several monkeys inside a room and if you give them banana, okay, which is hanging on the like from the ceiling, and if you put one chair or some stairs below it, and if you give some kind of electric current to that stairs, these are stainless steel or metallic stairs. So if that monkey wants that banana, he'll try to climb that stairs up and try to catch that, get that banana. But he'll get a shock, right? So next time onwards, he'll be very careful in climbing up that stairs, right? So that is a kind of intelligence. Okay. Any other ideas? Sorry? Ability to show what? Sympathize. Yeah. Giving condolences. Sympathize. Yeah. But yeah, when I'm finished, just like whenever you go to your respective colleges or cities, just whatever the answers that you guys are giving, just think about it deeply. Like you said me, what did you say? Sympathize. Yeah. So just think on it. Okay. So what does it mean by sympathizing someone, like or giving condolences to someone? Okay. Just cut it down into, just break it down and go to the very core of it. Go to the very basic understanding of human beings, of what sympathies, what condolences, what feelings are, what hormones are. Okay. So it will give you some insight inside this talk, as well as if you want to go into this field. Okay. Okay. Any other answer? Emotional intelligence. Yeah, kind of like similar thing. Okay. So like you guys gave me some like humongous answer, very technically profound answers. So the basic answers will be kind of these. So say I'm inside my home and I want to go out. Okay. But like there is too much sunlight outside and I'll wear some sandals or some shoes to go outside, right? Okay, I won't go barefoot. Okay, I will wear shoes and I'll go outside, right? That is an intelligence. Or is it? Is it an intelligence or not? Wearing shoes because you don't want to hurt your feet. It is intelligence. It is a sign of intelligence because it will connect you to the survival instinct. It will help you to survive in this world, right? Okay, this is survival instinct which helped the humanity or this all these living beings from several lakhs of years. Okay, next thing is Lego building. If you give babies some Legos, Legos are those cubes, small cubes. So if you give babies some Legos and he's trying to build a building out of those Legos by putting one over the top of the other, that is also kind of intelligence. He's trying to create something. Okay, opening locks with a key. Do you consider this as some intelligent thing? No, but it is intelligence. And tying a knot, just tying a knot or tying a tie, it is intelligence. Though these things are very trivial or very simple, these are the signs of intelligence. Okay, just keep that in mind. Okay, move on. So, can you guys tell me when was the first computer designed? Anyone? When was the first computer designed or invented? Or was it Apple II or Apple One or even before that IBM machines or in 1930s? Xerox built. Who said that? Zinniac, yeah, it was in 1950s, I think, or 1940s. Okay, okay, okay. Just listen to my question once again. When was the first computer designed, not built? Cheer up, man. Smile. If you're not getting interested in my talk, I can leave. Okay, but I want responses. Okay, yeah, yeah. But Lady Ada Lovelace didn't build or design a computer. Charles Babbage did. Okay. So the first computer was this. It is a humongous machine of the size of this entire campus, like CSA campus only. Okay. So this is an yeah. This entire machine is very complex. This is the top view. This is the top view of this machine. This is a cog, a giant cog. These are teeth of these cogs. All these are cogs and gears. Okay, this is a very huge machine, very complex machine, and it was meant to perform very complex tasks, very complex tasks, like adding two and three. Okay, so adding two and three was very complex at that time. Okay, so this was designed for that thing. Okay, so it is very huge, very complex. Okay, so Charles Babbage built that machine. Okay, not built, designed that machine on the paper, and it was too complex that nobody understood it. Okay, except one person. I'll tell about that person later. Okay, so nobody understood this machine, and this was built for like doing some arithmetic tasks like addition, multiplication, or division, or things like that. Okay, so if I want this machine to perform something, if I want this machine to perform an addition, okay, how would I do that? So let's say this machine is able to perform four things: addition, subtraction, multiplication, and division. So if I want to tell this machine that I want to perform addition, take these two numbers, 2 and 3, and add them. How would I do that? I need something to tell him, right? I need to ask him to do that task. right? So there was this idea that he got from someone of punch cards. Okay, what is a punch card? Punch card is just a small cardboard kind of thing which has holes at some specific places, right? So if I fix those holes into these teeth, into these teeth, okay, it will get fit there, and this entire system will move in some particular, in some direction, in some particular direction, and that direction is meant for addition. Okay, if I use some another punch card which has some different types of holes at some different places, it will perform subtraction just like that. Okay, so basically those punch cards, he made all of those punch cards, like for subtraction, addition, for multiplication, for various mathematical functions. He made those in original, but he never built this machine. Okay, he made those things but never the original machine on which they can work. Okay, so come back to the punch cards. So these punch cards in modern times, we call it as programs, right? So if I want my computer to do the addition, I will write the addition program, right? So that punch card, the addition punch card, it's similar to that, right? These are programs, addition program, subtraction program, just like that. Okay, so the next thing is this: who was the first ever programmer, and who, just let me come to the question, man. Okay, and who gave the idea of punch cards to Charles Babbage? Okay, so as he told, it was Lady Ada Lovelace. Okay, she was an English mathematician and she was the first programmer. But calling her simply as a programmer is kind of undermining her potential. She was not just a programmer. Okay, she was a futurist. She was a futurist. What do I mean by futurist? She can see some of the things that Charles Babbage he couldn't see. Okay, she could see the future. What this machine is capable of, she could see everything. That whatever that we are doing today with the help of machines, she saw all those things at that time in 1830s, like before 200 years. Okay, that's a huge leap. Okay, so this guy, the hero of our story, Charles Babbage, he built this machine. Okay, and he said that I designed world's most complex machine. Okay, then this lady came into the picture, Lady Ada Lovelace. She said, I understood it completely, and I understood what it holds for the future. I understood each and everything of this. Okay, and this. Okay, so this Lady Ada Lovelace took a leap even after that. Okay, so basically, this mobile, this my mobile, simple mobile, this is able to play the videos, play the audios, play the music. I can even play the games. Like you have, every one of you have like you have the smartphones. I assume that. Okay, you can play videos, audios, anything on that. But all it at the end of the day, all it boils down to is numbers. Okay, so on the chips, on the very core of it, all it is numbers. Okay, all of them are numbers. Even I can play video, I can encode them. There are some encodings. Okay, which I can run on chips, silicon chips. All of those are numbers and some mathematical functions. She saw that. Okay, but it was in the context of mechanical things, not electronic things, because silicon chips were invented much later that era. Okay, so she saw all of these things happening in her mind, and she told Babbage that I can see that on one fine day, this machine, this machine, this machine can even play the music. And Babbage was like, huh? How can it? So she said, if you represent, like if you like Charles Babbage, if you tell that machine what is the representation of a music is in the terms of numbers, say one note for one particular number, if you give that representation to the computer, maybe one day it will able to understand it and it will create the future. It will create the music for us. That's what she told. But like he didn't get convinced. Okay, Charles Babbage, because he was the hero. Okay. So he said, okay, ignore all that, but listen to this. It can add 2 and 3. Okay. He was not seeing the bigger picture. Okay. So she saw the bigger picture. Okay. That's why I call her as a futurist. Okay. So in 1843, she went beyond this and she made this statement. Machines could not have human-like intelligence as long as it only does what humans intentionally wants to do it by programming it. Okay. So this is the baseline foundation for artificial intelligence. Okay. She made this statement in 1843. So nearly 170 years ago. Okay. So this simple thing is the foundation of all the simple things that our machines or mobiles can do without programming them, right? Siri has its origin here. Okay. So everything that is, even you saw VR demos, right? So those VR demos have their origin in this. Okay. So So she was a great lady. That's it. Okay. So are these things really intelligent? The things that your mobile is doing, the Siri, the virtual assistant, Google Ads, the recommendation system, all those things, are they really intelligent? Are they really intelligent? What is mean by intelligence here? Okay, is Siri really intelligent? So if Siri has my like if I'm sick and if my doctor gives me some prescription, and if Siri reminds me of taking the medicine according to my prescription, okay, based on some data. So do we call this as intelligence? Because my mother does the same thing, right? If I'm sick, she'll tell me take these medicines, okay, on some particular time, right? 4 in the evening or 5 in the evening. So Siri is doing the same thing, right? So do I need to call her as intelligent, or just some virtual assistant which works on data and patterns? What do you think? Those who think that it is intelligent, just raise their hands. Okay, I have my hands raised. Okay, no one else. Okay, no one else is agreeing. Okay. So for that, we need to understand what is intelligence. Okay. So now forget about human intelligence, forget about computer intelligence or machine intelligence. Just basic, like at the very core of this universe, what does it mean by having the intelligence? Intelligence. Sorry? Ability to think. Okay. Or having intuitions. Plan? Yeah, logical reasoning. Anything else? Yeah. Ability to make decisions. And laziness, do you think is it intelligent laziness? Because many of the inventions that we are having today, this fan, this projector, even the computer, even the railway engine, because we don't want to walk, okay, that's why we created bikes and cars, okay. So laziness is kind of intelligence. Okay, anything else? Okay, so things like that are intelligent. So maximizing chances of achieving leisure with minimal efforts. That is laziness. Laziness in proper terms. Okay. So if you're lazy, don't say you're lazy. Say this thing. This is technical jargon. Okay. Being aware about self. Okay. That is kind of intuitional. I'm being aware of what I'm doing. I'm talking to you guys, right? And you guys are not responding. So this is kind of being aware. Okay. So these things are like baselines of what intelligence is. In 1637, the father of coordinate geometry, René Descartes, who invented the Cartesian system, said this statement: I think, therefore I am. So what does that mean? I'm thinking, right? That is the proof of my existence. That is the proof of my existence and my intelligence, right? So he said that. So there were many these. This is kind of philosophical question. It's not a technical question. AI is like today's AI is 60% of AI is like philosophy only. Okay, you need to set some rules and then you need to quantify those and then you need to do something with the algorithms and all. Okay, so there were many confusions like that and many bright minds like you guys were there at that time also. They wanted to do something in this field, but there are many philosophies and nothing else. Nothing tangible was there. Okay, nothing quantifiable was there. Only philosophies. So this guy came into the picture in 1943. Okay, so he wanted to do something tangible. Okay, something on which he can work. Okay, so he disregarded all these sayings and all these conceptions and misconceptions and philosophies for AI or intelligence or creativity, and he came with this intellectually profound response. He was being like a very talented guy. So his very awesome reply was this: screw it. So he screwed all of these things, okay, all of these things, and he wanted something tangible, something quantifiable. Okay. Okay. So before moving to that, just a small thing. How does a plant eat? Okay, this is a question. Okay, plant they don't eat in our usual way, right? They don't have hands, they don't have mouth. Okay, we humans we have hands. We take food, we put into our mouth, and we digest, right? That's how we eat. Okay, but plants they don't do like that. Okay, their roots are in the soil. They take ingredients and fertilizers from the soil, okay, and they supply those all those nutrients to branches and leaves, right? So it is not the conventional way of eating, right? But you cannot say that it is not eating. It is eating in its own way, right? So Alan Turing thought the same. Okay? So he said that if something is not thinking in a conventional way, it doesn't mean that it isn't thinking at all. It is thinking, but in its own way. Okay. So now tell me, can machines think? Respond to something. Yes, no. Yes, in their own ways. Okay. Who all are there? Who are saying no? Say something. Only these few guys said yes. Okay. Okay. You do this kind of thing in your lectures also. You are in third year. I did the same. Okay. But try to respond. Okay. Ask doubts. Try to respond. It will give. It will get you somewhere, right? It will help you go places. Right. Ask doubts. Not to me. Okay. Because I'm not the expert in this. But ask doubts to your teachers. Okay. And respond. Okay. So before that, I want you to listen to something. I'm playing some audio clips here. Okay. These are some melodies, some beautiful melodies. You can even close your eyes if you want to feel those melodies. Okay. I'll play the sound. Is it working? Sounds. Are these about these two music about first and third? Are they beautiful? Okay, actually there were three songs or three musics. Okay, so three pieces of music. So what if I tell you that out of these three music, one is made by computer, one is made by machine. Okay, and artificial intelligence. So can you guess which one was it? Don't tell me that like the one which didn't play. Third one. And all of these are melodies. These three were the same. Okay, unfortunately, I couldn't play that one. Okay. Any other answer? First one. Well, my probability already got reduced because of that song. Okay. So both of these songs that you heard were made by computers. Okay. Not only one. Both of these two songs. And some of you failed this test. Okay. In guessing that. So basically, that what Turing said, he wanted something tangible, right? Okay. So this tangible is this thing. This tangible is that thing. Okay. So he said something tangible, something that I can quantify is a machine would be considered intelligent if its conversations or creations couldn't be easily distinguished from those of humans. Okay. So these are three clips. Okay. Only this one was made by human, and these two were made by computers. Okay. And that didn't play. Okay. So this was something quantifiable, right? What do I mean by quantifiable? Which I can convert into some mathematics and I can process and work on it, right? That's what I mean by quantifiable. Okay, so okay, we have a few more minutes left. So okay, so Turing predicted this was around 1950s. Okay, so Turing predicted that by the year 2000, okay, 2000, the machines which have like say 100 MB of memory, 100 megabytes of memory would easily pass this test. Okay, would easily pass this Turing test that you cannot differentiate between a human and a computer according to the responses. Okay, so what do you think? Like, are we on that stage or not? We are definitely not on that stage. If you sit for say 1 or 2 hours and analyze these three music, you can easily spot the differences. Okay, it's not that tough. Okay, even if you have virtual assistants in your mobiles, okay, Siri or some say Google Assistant, try to ask him 4 to 5 continuous questions. Ask him what is your name, okay. Virtual assistant, ask him what is your name, then ask him what is 3 plus 2, what is 4 plus 5, then ask him who's APJ Abdul Kalam, and ask him the next question as what was the first question that I asked you. Okay. So he cannot respond. He'll give some arbitrary answer or he'll return the results from the web page. Okay. So he'll do that. Okay. And if I ask those same questions to my friend here, okay, what is your name? What is 3 plus 2? What is 4 plus 5? Who was APJ Abdul Kalam? And what was the first question that I asked you? He can respond me, right? So in that case, I can easily identify who's human and who's a computer. Okay. So still we are not there. Like we cannot make the machines which can easily pass the Turing test. Okay. So we are still not there. Okay. So creativity. Now we can discuss creativity because we know what basic intelligence is. Okay. We cannot talk about the creativity if we don't know what intelligence is. So creativity is the ultimate moonshot for artificial intelligence. Why is it that? Why is that so? Because creativity needs much technical improvements, technical leap that we yet have to take. Okay. So not now, but maybe after 50 or 100 years, we will be able to do that. Okay. So creativity. What do I mean by creativity? Nowadays, did you watch this movie called Morgan? It was a horror movie. It released in 2014 or 15, I think. Okay, so if you didn't, go watch that movie, or at least watch the trailer of it on YouTube. Okay, there is a trailer of Morgan, Morgan. The trailer was entirely made by a computer. Okay, so there was no human, like no human made that trailer. Computer made it. Okay, watch that trailer. It's you cannot differentiate between a trailer made by human and by like made those by computers. Okay, so this current AI in creativity, in the context of creativity, it is helping us in filmmaking. It is helping us writing poems. It is helping us creating great musics like these, the first one. Okay, it is helping us. But there is one small glitch. Okay, I'll tell you about that glitch. Okay. Okay, so our task is to create a beautiful piece of music. Okay, I want to create a beautiful piece of music with the help of artificial intelligence. Okay, with the help of AI. Okay, what should I do? The very first thing I can do is I can hard code the machine to do so. Right? I can just code it. This is this. This is this. This is this, and that will play. But that is definitely not a creativity. Right? The second thing I can do is I can generate random numbers. I can assign one musical note to each number. I can generate all those patterns. Right? But the problem here is it will be much of a noise than some useful or beautiful melody, right? The third and tangible thing is open your eyes and look around how nature works. How nature works. Nature is working since Earth got born, or since we are here. From like we were Neanderthal, right? We were Neanderthal man. Then we came to Homo sapiens. Then Homo sapiens sapien. We are still Homo sapiens sapiens, right? So this process is called evolution. Okay, Darwin said that few centuries ago. So this is evolution. This is how nature works, not we. Okay, not we in the AI context. Okay, so just look at that. Just look at how nature works. It works on evolution, and at the core of it, it is survival instinct, right? So survival of the fittest. So whoever that is fit, it will survive, right? So we humans were fit enough before several lakh years. That's why we survived, and you are attending my like this talk, right? Because you were fit, and you are fit. Okay, you are smart. Okay, so this is how nature works, and so some people thought that why like let's apply this kind of things to artificial intelligence or to the algorithms of artificial intelligence. So my task was to create some beautiful piece of music. Okay, so I'm applying this evolution kind of thing to this. Okay, this is my raw data. This entire is my raw data. Okay, I have hundreds of songs and its musical notes. This is hundreds of songs. Okay, only 4 are here. Okay, there are several songs, several more songs. This is my raw data. Okay, what I do is I take several pieces out of this data. Okay, and I'll mix them, I'll interchange them randomly on the random basis. Many pieces of data randomly for many iterations. Okay, so I'll do this many times, and I'll create something new set of music like this. Okay, it's random. Then what I do is I'll give you what I think as beautiful. Okay, I think some songs are beautiful, so I give shit music of those songs to that algorithm, okay, or to that machine, and ask him to compare it. Okay, so the data it created was this, and I gave him this beautiful music, beautiful as of like I'm considering it as beautiful, not machine. Okay, so I helped the computer here in this step, and what computer does it compares these things and it finds some similar things like this and like this. So it tries to focus on those things more. Okay, so those beautiful kind of things more, and it performs these actions for many generations or iterations. It performs the similar thing. I'll give him something beautiful. It tries to compare and try to mimic what is beautiful, what I think as beautiful. Okay, it will do it for many generations, and you will get your piece of music. Okay, you'll get this final result, and this final result was that first or second clip that I asked you to listen. Okay, so this is my final result, but there is the small star. Small star is always there. Nothing comes free. Okay, this is condition supply, and the condition here is this human assistance. So we needed human assistance in this step. In this step, we needed human assistance. Okay, so it is creative. It created some music, right? But not without human intelligence or human interaction. Okay, I told him that computer that what is beautiful, and it compared and it produced that music, right? So human intelligence. Okay, so still the basic question still remains as it is. Still the computer is creative, right? It created some kind of music for me, okay, and some VR kind of thing. Okay, but still, can I call this as creativity? Because he needed some human assistance here. Okay, you guys, like, if you have some plan of, if you think of some novel idea, okay, from where do you think it is coming from, that idea? It is coming from the surrounding, right? Nature is helping you, right? You take your say I got this, Elon Musk got this idea of making an electric car, okay, powerful electric car, okay, but how did he get that idea? He saw what the people are doing, and he saw the, like, fuel diesels are not that much sufficient, right? So he saw all these things, all these constraints, and he thought of that idea, right? So nature was helping him. In this case, I was helping it. I was helping this algorithm in this stage, right? In this stage, I was helping him. So still, it is not clear what the human creativity actually is. So it is just the random chaos and orders in our connections of the neurons in our brain, or something more than that, something intangible, something like soul, right? But there is no soul. Okay, so is it something like that? So the still the basic question is as it is. So the thing is it enough to create something beautiful and original for us? Okay, like those music pieces, or it should be done with the intention about what is being created and like being aware about it. So is computer aware about what he is creating? Is computer is not aware about like about the things he is creating, right? He was not able to pursue it as music. It was just a normal numbers and data for it, right? So still it is like, it is again a philosophical question. We cannot still determine this, and we cannot still say that it is a creativity or not a creativity. Okay, so if there comes a time where, like, if I give computer a picture and without any human assistance, it can define this picture as beautiful from the scratch. Isn't it? Isn't this picture beautiful? Isn't it? Boys will find it beautiful, right? Okay, this picture is beautiful. There are many colors, right? So if I give this picture 50 years later to some computer, okay, it can identify the patterns, the pixel arrangement, and choice of colors, and without any human assistance, it will say that this picture is beautiful. Okay, that will be a huge leap. Okay, I'm not giving something like, I'm not giving that computer what is beautiful and what is not beautiful. It is deciding by itself. Okay, so it needs a much technical and, sorry, philosophical advancements. Okay, so this thing needs, if we just try to do this randomly without any kind of algorithms, genetic algorithm, that I, this thing I just told you was kind of genetic algorithm because it was working on evolution, right? It was evolutionary algorithm. So evolutionary algorithms are like better known as genetic algorithms. Okay, so if I just try to do this randomly, okay, I don't know what beautiful is and what is not beautiful, and if I just write some random algorithms, give it some random pictures, it will create some of the results. Like computer will give some of the results, but there will be much of a noise. This is one very good statement that I found on the net. It is very easy for AI to come up with something novel. Okay, ideas are novel, ideas are creative, ideas are something that are originated between us, right? So something novel just randomly, but it's very hard to come up with something that is novel and unexpected and useful. So this thing is important. Okay, I can create that is good. Okay, so I can create some flying car. Okay, but is it efficient? It is not efficient. I cannot like according to some rules of physics or according to some basic constraints that our civilization has. Okay, I cannot design or make that flying car as of now, right? So it is not useful. Even if that is some novel idea, some new idea, some creative idea, it is not useful. So it is very hard to do this thing. Okay, so if we ever reach to that point after say 100 years, I'm being optimistic about it. So it's nothing like that. Like those things they show in the movies, like robots overcame the humans, okay, and they're now ruling the humans. Like in some of the movies, they showed the things like this, right? In iRobot and those kind of movies. So there is nothing to be scared of. Okay, even before that, we'll vanish from this earth because we have much bigger problems. We don't have a sustainable energy resource. We have this major problem of global warming. Okay, do you know what global warming is? Okay, if you don't, watch this movie of Leonardo DiCaprio, Into the Floods. It will, yeah, it will teach you some of the things. It is a very serious problem, but many of us are not aware about it. Okay, these are critical problems. So if we ever reach that point, which need this solving this problem needs much of processing, much of computation, and even before that, it needs much of creativity. It needs some original ideas. Okay, so if we get to that point where computer is being creative, so we can solve these problems. The problems like this: global warming, world economy falls, international relations. Okay, the relations between America and say Russia or India and Pakistan. These are tense relations. Solving these relations or solving the question of Kashmir is now beyond the human effort, right? We are trying it for say last 60, 67 years, but it is still not getting like it is not solved yet. Okay, so the questions like that or creating sustainable energy resources. Okay, these are some problems that we are facing, and if we don't solve these problems, even take just one problem, global warming. If we don't solve that problem, and with the current rate of global warming, we will vanish from this earth in next 200 and 300 years. We'll have to leave this planet. Okay, that's for sure. If you don't solve it now, okay, and that will need in future some creativity from the AI side. Okay, and many more problems like that. So I'm being optimistic about what the future holds for us. Okay, don't get scared what movie shows you. Okay, just be optimistic and let computer help you, and you help computer to grow. Okay, and we all will grow together. And just like you guys also just smile if you're being optimistic too with me. Okay, thank you.
Thank you, Tushar, for this wonderful talk. I just wanted to give a surprising news. Tushar, by the way, is don't you agree it was a very creative presentation? Tushar is not a human being; he's a computer. Thank you, Tushar.
Thank you.
So